Water is at the heart of civilization. Every human being must have water, and large concentrations of people require a lot of water. For millennia, engineers, sometimes under other names, have played a critical role in supporting civilization through the provision of adequate water supplies and also in disposing of waterborne wastes. In this presentation, we will delve briefly into the history of water-related innovation and policy and examine the importance of these developments to society. Ideas and innovations related to water are as old as society itself, so we'll start off way back. As early as 4000 to 2000 BCE, Sanskrit writings of the Hindus advocated such water treatment as boiling, exposure to sunlight, and filtration using sand, gravel, and/or charcoal. They even discovered some mineral and vegetable substances, today recognized to be coagulants or polymers, that could purify water. Ancient Indian civilizations also demonstrated significant achievements in the areas of water supply and sanitation engineering, like the Great Bath at Mohenjo-Daro, the world's most ancient public water tank. The early Egyptians, too, around 3400 to 2450 BCE, had several water innovations, including rainwater harvesting techniques and sewage disposal. Later Egyptians, around 1580 to 1200 BCE, used extensive irrigation systems. The predecessors of the ancient Greeks, the Minoans, lived on the island of Crete around 1850 to 1400 BCE. In the palace at Knossos, they supplied fountains and faucets with water piped underneath the floor and maintained an extensive network of sewers. The Minoans are even credited with developing the first known toilet, a technology that was later lost for centuries before it was revived. The Romans first started building sewers around 800 to 735 BCE. The sewers carried surface runoff from storms as well as human waste, which was mostly manually dumped into them, as only a few people had direct sewer connections from their latrines. These connections provided the only source of ventilation for the sewers and were very stinky. The largest Roman sewer, called the Cloaca Maxima, was built around 500 BCE. Around the same time period, about 700 BCE, Greek civilization was flourishing, and their water innovations included hot and cold water connections in their gymnasiums, although they had very utilitarian bathing routines and did not develop bathhouses to the same extent as the Romans later did. Greeks were also effective in protecting their water sources to keep them operating during long siege periods. Hippocrates, the famous Greek physician who lived from 460 to 354 BCE, recognized that water contributes much to health, and even created the Hippocrates sleeve, a cloth bag for straining rainwater. Although they built other aqueducts earlier, including this one in Istanbul, Turkey, called the Valens Aqueduct, by 312 BCE, the Romans were building their aqueducts into Rome itself. The system into Rome had over 220 miles of aqueduct, mostly underground, and carried 40 million gallons per day. The Romans were careful to check their sources of water for purity. They did so by seeking clean-looking water and surveying the health of those in the community using that water supply. They employed people to fix leaks in the system and maintain it by cleaning out excessive calcium deposits. Coincidentally, thin deposits of this type protected the water from being contaminated by the lead pipes. One aqueduct in Spain, built between 98 and 117 CE, is still used today. The Romans also found several mineral and vegetable additives to water to improve the taste. Roman civilization constructed a system of huge bathhouses with pools for bathing and also communal toilet rooms. There were 11 public baths and 856 private baths by the 4th century CE. About the time the Roman civilization fell, around 400 CE, the Mayan civilization was flourishing in what is now southern Mexico and northern Central America. In the center of Palenque, they created drainage for plazas and routed streams underground to control flooding and create more space. The Mayans even used water pressure to create a fountain which could lift water as high as 20 feet above the ground. This effort represents the first known use of pressurized water in the Americas. While the exact purpose of the fountain is not known, the fountain may have facilitated access to the water or made it easier to fill water jugs. When the Roman Empire fell, many of their developments in engineering and health were lost, and quality of life deteriorated in the Dark Ages. Very little by way of water-related innovation occurred in Europe for several centuries. One of the few milestones worth noting is the passage by British Parliament in 1388 of a law prohibiting waste disposal in ditches, rivers, and waters. Also, in 1589, Sir John Harington reinvented the water closet or toilet after it had been lost. Sir Harrington created the water closet for his godmother, Queen Elizabeth, but the device never caught on with anyone outside of the palace, and toilets were again abandoned until the 1700s. Finally, in the 1760s to 1780s, toilets began to come back, with Alexander Cummings and Joseph Bramah improving the designs. Contrary to popular opinion, the aptly named Thomas Crapper, who lived from 1836 to 1910, did not invent the toilet, but he did patent several improvements in toilet design. Other toilet-related developments include the popularization of public lavatories by George Jennings, most notably at the Great Exhibition of 1851, where over 827,000 people used the necessary convenience, which they had to pay to do. By the 1880s, a new one-piece toilet design was brought into use by Thomas Twyford. His design greatly reduced foul odors produced at the joints of older two-piece models. Meanwhile, even with the advent of sewers in London in 1800 and their adoption elsewhere around the same time, conditions were quite unpleasant due to a lack of any actual treatment of the sewage. Disease outbreaks were quite common, and it was not until 1854 that water began to be definitively linked with the spread of disease. During a cholera outbreak in London, a doctor named John Snow and another man named John York managed to track the source of the outbreak to a particular pump, the Broad Street pump. Snow obtained permission from the authorities to break the pump handle, and he effectively stopped the outbreak. A replica of the pump now sits at the original site across from the John Snow pub. The summer of 1858 in London was known as the Great Stink, where putrid sewage odors from the Thames River blanketed the city. The drapes in Parliament were soaked in chloride of lime to try to save the members of Parliament from the stench, but the effort was in vain. In less than 3 weeks, a bill was passed to upgrade the sewer system in London and better manage the flow of wastewater. Conditions in some American cities were no better. An 1865 sanitary report for New York City by Dr. John Griscom discussed the plight of some 18,000 people living in dwellings below the high water mark. At very high tide, the water often wells up through the floors, submerging them to a considerable depth. In very many cases, the vaults of privies are situated on the same or a higher level, and their contents frequently ooze through the walls into the occupied apartments beside them. And it was not until 1867 that Chicago changed to a water supply on Lake Michigan rather than using the sewage-contaminated Chicago River. In 1900, Chicago even undertook the largest earth-moving project of that time to reverse the flow of the Chicago River and use Lake Michigan water to dilute sewage in the river. In the 1880s, several cities in the U.S. built aqueducts to supply the cities with the drinking water they needed. In 1890, the first treatment plants for water were put into commission. The 1880s and 90s saw some other significant developments in water and sanitation engineering, including the discovery of slow sand filtration by British scientists in 1885, Ellen Swallow Richard's study of water pollution throughout the state of Massachusetts, the first study of its kind, in 1887, and the passage of the Rivers and Harbors Act in 1899, which made it illegal to dump any garbage, except liquid sewage, into a navigable waterway. After Robert Koch, the father of bacteriology, discovered that hypochlorous acid, or HOCl, could be used as a disinfectant, chlorination of water began to be used in the U.S. The first city to use chlorine in the water system was Jersey City, New Jersey, in 1908. Once other cities started adopting the practice, the incidence of diseases like typhoid fever decreased dramatically, as seen in this graph. Rates in 1920, when the graph starts, were already down to only half of what they were at the turn of the century. In 1919, a method was developed to more accurately determine the correct dosage of chlorine, leading even more cities to adopt this life-saving strategy. More large-scale water projects emerged in the early to mid-1900s. William Mulholland directed the building of canals to bring water to Los Angeles beginning in 1913. Unfortunately, one of the dams for which he was responsible, the St. Francis Dam, gave way in 1928 and killed over 500 people. British chemists developed the activated sludge process for wastewater treatment that is still used today, and the system was put into use at a small British plant in 1916 and the first large-scale activated sludge plant on Lake Michigan's shore in 1923. The year 1935 saw the completion of the Hoover Dam near Las Vegas, and 1937 the start of construction of the Delaware Aqueduct system. A year later, the Colorado Big Thompson project began. The project brought water from Colorado's western slope to the farmers and cities of the Front Range and took almost 20 years to complete.